Welcome to Maths with Bob. Today we're looking at triangles, right triangles actually, and naming the sides and the ratios actually. So the first thing is we need to grab a triangle. Oops, here's the triangle. Right, okay. Okay, the first thing to realize is that, okay, for each angle, theta, now theta, here's theta. Well, this is theta, okay. Theta is, well, a Greek letter, which is used to represent an unknown angle. Now, how can we actually define this angle theta? Well, we could measure it. Okay, if we had a protractor, let's grab a protractor and have a quick look. Okay, we can see it's, say about 28 degrees, okay. But let's say we didn't actually have a protractor, okay, and we wanted to try and work out some way to define this angle. Okay, well, if we actually look at, hold on, this is the wrong one, hold on, we need to actually look at this triangle, and the other triangle. Now, those three triangles are all similar, okay. Now, something about similar triangles we're going to use, okay. So let's have a look. Why are they similar? Well, hopefully we can see that for those three parallel lines, we've got corresponding angles which are equal. The theta is shared with all the triangles, and the right angle obviously is shared with all the right angles. So we have what's called an equiangular situation in similar triangles. So when we think about similar triangles, we think, wow, sides in proportion, okay, the ratio of the sides are in proportion. Okay, so for each particular angle, if you look at those three triangles, the ratio of, say, let's have a look, this one is called the hypotenuse, okay, that side to, say, this side, which is the opposite, is in fact going to be the same as this ratio to this ratio, which is also, okay, so each angle will have, if you like, the same ratio. No matter what size the triangle is, the ratio of a particular set of sides will be the same. And this is how we can actually define an angle. Okay, so the first thing is, okay, let's have a look, the hypotenuse. Okay, well, the hypotenuse, well, most of us know, I think, from Pythagoras, is in fact always opposite the right angle. So here we have lots of right angles. Okay, here's the right angles, and this is the hypotenuse for all of those triangles. Okay, now, let's have a look. Which one's the opposite? Well, this one is pretty obvious, the opposite. Hopefully we can see that, in fact, the opposite is always opposite the angle, okay? So for all those triangles, that would be the opposite side. And there's only one other side left, which hopefully must be the adjacent side. Okay, so this must be the adjacent side down here. Okay, and this is just adjacent to the angle. Some people say it's adjacent to the angle, and it's basically not hypotenuse, and it's not the opposite, I guess you could say as well. Now, okay, so here we have hypotenuses, opposites, and adjacents. Okay, so how are we going to, well, get the essence or define this angle? Now, we know that the ratios will be the same, so the ratio of, say, the opposite of the hypotenuse, or the adjacent on the hypotenuse, or the opposite on the adjacent, in fact, will be the same for a particular angle. And so we give these particular ratios names. Okay, so opposite on hypotenuse is called the sine. So let's have a quick look at the, now, there is a way to remember these. I'll just, we probably have heard of this phrase called SOHCAHTOA, but basically this particular phrase is a phrase used to help us remember these ratios. Okay, now SOH means sine is opposite on hypotenuse, cos is adjacent on hypotenuse, and tan is opposite on adjacent. So the three ratios are called sine, cos, and tan. Okay, and they're abbreviated to the calculator. If you have a look, we have sine, cosine, and tangent. Now, these are abbreviated to this one, sin, this one cos, and this one tan. So these are the three buttons on the calculator which we use. While we're on this, we hopefully know that angles are measured in degrees, minutes and seconds. Now, each degree is made up of 60 minutes, which is made up of 60 seconds. It works a bit like time. Okay, so if you wanted to get a degree, you chop it into 60ths, they would be minutes. Then you get a minute and you chop it into 60ths, they are then seconds. So we've got this button on the calculator called the DMS button. It's a button that looks a bit like this. Sometimes we used to call it the OG button. Sometimes OGG, OG button. That's, yeah, or sometimes it's actually a button like this. Some calculators DMS. Okay, but basically it is in fact the degrees, minutes and seconds button. Now, let's have a quick look. Okay, here we have sine, opposite on hypotenuse, cos, adjacent on hypotenuse, and tan is opposite on adjacent. Okay. Well, okay, now that we know that some of these ratios have given names, sine, cosine and tangent, let's actually start to apply it to a problem. Okay, here we have a couple of triangles. You can see here they are 60-30 and 45-45. Now, they're called exact value triangles. They're very special triangles. If you actually have a look in your geometry set, you'll see you've got a 60-30 set square and a 45-45 set square. It's the same the world over. Okay, so these are actually called special angle results. They give us the exact values for particular angles, these ratios. So let's actually have a quick look. Okay, so let's have a look. Now, say I wanted to find the sine, let's say 60 degrees. We know that if you're looking here, sine is the opposite on the hypotenuse, O1H. Okay, so let's try and work out what is the opposite of 60. Well, where's 60? 60 is here. Yes, that's a 60. What is the opposite? Well, crikey, the opposite of 60 is here. What's the opposite of 60? That's right, root 3. How about the hypotenuse? Okay, well, let's have a look. Biggest side of the triangle? Yes, it's 2. So sine of 60 we could write as equal to, the opposite, remember, was root 3 over 2. So the sine of 60 is exactly equal to root 3 on 2. How about the, let's have a look, say the cosine of 45. Let's have a look at the cosine of 45. We know the cosine of 45 is, in fact, from here, adjacent over the hypotenuse. Okay, let's actually have a look at this. Okay, which one is the adjacent? Okay, this one here is the adjacent. Yes, that's the adjacent. Which one's the hypotenuse? It's this one up here, root 2. Okay, so that equals, let's have a look, 1 on root 2. Okay, we may have to stop it there. Well, if we actually just have a close look at this, well, you can see here I've written sine brackets theta, cos brackets theta, and tan brackets theta. So I'm trying to emphasize that the actual theta is a variable, and these are functions. I can't alleviate that theta easily, and I'll explain a little bit more about that in a minute. But we're going to have a quick look at the reciprocal ratios in a second. And if, suppose in those similar triangles I selected the hypotenuse and put it over the opposite, I'd get a different ratio. And same with the adjacent hypotenuse. If I put the hypotenuse over the adjacent, I'd get another ratio. These are called the reciprocal ratios. Okay, they're given different names. Okay, let's have a quick look. Here we are. We have sine's reciprocal is actually cosec. Cosine's reciprocal is secant. And tangent's reciprocal is cotangent. You can see here they're abbreviated to cosec, sec, and cot. There's no buttons for these on the calculator. And how you find them is you find the sine, cos, or tan of the angle, then you use the reciprocal button to find these ratios. Now, when we start using trigonometry, a lot of people think we can actually get rid of that sine in front of the theta, but the sine is actually attached to the theta. I always think of it like it's a wrestler the wrestler actually has the theta in a headlock, and there's no easy way to get that theta out unless you use a bigger wrestler called the inverse sine wrestler. And this is actually the idea of applying an inverse function to get the actual variable out of the original function. Now, we're going to start to have a look at some of these ideas and some examples in my further videos, but just something while I'm here, I just want to show you something. Someone actually pointed out to me, if I go along 1, 2, 3 letters in cosec, I've got an S. So cosec's reciprocal is sine, or you could say sine's reciprocal is cosec. If you look at sec, you can see here that in fact 1, 2, 3, sec's reciprocal starts with a C. So sec's reciprocal is a cosine, or the reciprocal of cos is sec. The same thing with cot. If you go 1, 2, 3, okay, cot's reciprocal starts with a T, or if you like, the reciprocal of the tan is cot. Okay, so we're going to apply some of these ideas. We normally usually only use sine, cos and tan, but thank you for watching. Bye for now.